Hello, welcome to my video covering setting up the dataset for a machine learning model built from scratch with Burn. So basically, to begin, I created a whole bunch of data using an app of mine called Stunts. I created a whole bunch of motion paths, which are basically collections of keyframes, so that I can build a model which generates keyframes. This is what the file looks like after being saved out of Stunts. Not all of the data is necessarily needed, but a lot of it is very helpful to have. However, in this format, it's not exactly very usable to feed easily into the model. So there's a number of steps that were taken to prepare this data set for the model. Now, what we're looking at here is the initial repo for Common Motion 2D. This repo was based on transformers, a transformer architecture, but that didn't work out very well for this task. I definitely gave it all it's got and really tried the transformers, but they weren't really appropriate for the task at hand. And that actually happens to include various changes, such as using a digit-based tokenizer. So anyways, back to the main topic. We essentially want to get the data into something much more usable, and this is what we end up with. So basically, these are considered the prompts for these markings, and this is considered the completion. And each one of these separates a sample. So this way, we can break up the data and process it in the model efficiently, accurately, everything goes well. So basically, to begin, I built a number of Rust scripts just right here in the bin folder so that I can essentially transform the data. These are all relatively simple, short, easy, and one thing that happened in this one was splitting it up into a training set and a test set so that we can train the model, of course, but also give it some data that it hasn't been trained on and make sure that it works with that data as well. So basically, out of this, we got some CSVs, and they looked a bit like this. Simple, but not exactly the end result that we wanted. For example, the coordinates, which these are the coordinates, this is the dimensions, this is the timing, and this is the object index. So the coordinates were in absolute pixel values. One of the things that wound up changing to help enhance the quality of the model was converting these to percentages. So, anyways, after transforming the JSON into a CSV file, accounting just for the positions on this first iteration of the model, so no rotations or opacity, nothing like that. After this, we simply came to a stage where it was important to actually augment the data. So we needed to basically quadruple the size of the data set by introducing small changes in it throughout. This generally will help the models learn the patterns better because there's a little bit more variability, but the patterns themselves stay the same. So in this file, a certain change was given, a random number in between these values, a random number in between these values, and that's how the data was augmented. So we can see that here. Then, after working with the transformers for a while, I started experimenting with some different architectures and found that they were performing much better, they were faster and more lightweight, which is all very good. So that brings us to the other repo. So first of all, I converted the data that you just saw to percentages on the coordinates. Because what I found was the motion paths initially were being learned fairly well, but they were scrunched up and not necessarily wide and long like I wanted them. And part of that could be due to the training data, but part of it seemed to be the lack of percentages being used. So that's what this script does. Pretty simple. Considers the dimensions inside of the target application. I also discovered that if I wanted them to be nice and wide and long, it was good to stretch the percentages so that numbers closer to 0 would go down to 0, numbers closer to 100 would go up to 100, and it would stretch evenly in those directions. So I augmented the data further to artificially stretch the motion paths. And that worked very well. That helped enhance the quality of the inference very much. Finally, as I was continuing to try to improve the quality, I decided to add the direction, the current direction of a motion path to the data. So after it was stretched, this is more what it looked like. So you can always see that some of the values go to 0 and some go to 100. After adding the direction, in theory, this provides the model with some more guidance in terms of which way the paths are going. And I found in practice that this did add just a little bit of quality to the outputs. And that's basically everything that went into preparing this data set. There was a final step where I needed to extract the mean and standard deviation values from the data set, which essentially helps produce a normalizer. And the normalizer is pretty important for stable, effective training. So there you go. There you have it. That is how I prepared the data for this model. Thank you.